By definition, so no reasoning. It's useful, but by definition, this is what dot product means. You can't normally multiply vectors. So we have two types of products, which means multiply, but they have special definition. The first one is dot product. And today it's dot product, or this lesson is dot product of geometric vectors. The dot product of A dot B is magnitude of A times the magnitude of B, cosine of theta, where theta is the angle between them, tail to tail. Very specific. And theta is always less than 180. Okay, tail to tail is theta, mag A, mag B, cos theta, theta, angle between them, tail to tail. All right, example 1. Magnitude of 4 for U, magnitude of 6 for V, angle between them is 120, U dot V. U dot V then is mag U, mag V, cos theta. So we have 4 times 6 times the cos of 120. We get negative 12. So U dot V is negative 12. A scalar. The result of dot product is a scalar, negative 12. Find the angle between two unit vectors. Unit vectors have a magnitude of 1 with a dot product equal to 1 over root 2. So mag A, mag B, cos theta, we want the angle between them, is 1 over root 2. Now, unit vectors have magnitude of 1, so mag A and mag B is 1, so cos theta is 1 over root 2. And that means theta is equal to 45 degrees. So the two unit vectors have an angle of 45 degrees between them. Properties of dot product. A dot B is a scalar, a real number. If A is perpendicular to B, then A dot B is 0 because theta is equal to 90 and cos of 90 is 0. If A dot B is 0, the magnitude of A or magnitude of B or either of those is 0, or they're perpendicular. You don't know which, but usually we use the dot product equal to 0 to define things that are perpendicular. If theta is less than 90, then the dot product is positive because first quadrant, cosine is positive. If the angle is between 90 and 180, the cosine of that angle is negative. It's the second quadrant, right? And the dot product will be negative. If A and B are parallel and in the same direction, that's what those arrows mean. This means parallel and in the same direction. Then the angle between them is 0, and A dot B is just magnitude of A times the magnitude of B. If they are parallel and in different directions, then theta is 180, and of course the cos of 180 is negative 1. A dot B is the negative of magnitude A times magnitude B. A dotted with itself is magnitude of A squared, okay, because cos of 0 is 1. A dot B is equal to B dot A. Commutative property applies. A dotted with B plus C, distributive. So you can distribute dot product over vector addition. You can also do commutative property of scalar multiplication over dot product. And A dotted with the 0 vector is 0. All right, use the dot product to prove each situation. Example 3a. So, okay, we want to prove this. So we'll do left side. Is magnitude of A plus B squared. Okay, squared. So we do A plus B. Remember, magnitude squared is equal to a dot product with a vector with itself, right? A dot A is magnitude A squared. So A plus B magnitude squared must be equal to that. Distributive property. So we're just foiling it, right? Foiling. A dot A plus A dot B plus B dot A plus B dot B. So A dot A is magnitude A squared. B dot B is magnitude of B squared. And because commutative property, these are actually the same. So we have 2 dot B, 2 A dot B's, and that's equal to the right side. A is done. Try this one yourself. Start with the left side, very similar to the last one. See what you can do. Pause the video and try it yourself. Right? Magnitude square means the vector dotted with itself. So it's A minus B is A dot A minus A dot B minus B dot A, negative B dotted with negative B, so positive B dot B. So A dot A is magnitude of A squared. B dot B is magnitude of B squared. We have, because of the commutative property, 2 A dot B's, so minus 2 A dot B's, which is equal to the right side. That one's done. And then part C, start with the left side. So A dot B dotted with A minus B, FOIL that out, so that's A dot A minus A dot B plus B dot A minus B dot B, and that is equal to A magnitude squared minus B magnitude squared, and those A dot B plus B dot A, they're opposite and equal, they cancel each other out. Example 4, a vector 2a plus b and a over 2 minus b are perpendicular to each other, and 2 mag b's is equal to 3 mag a's. Then find the angle between them. Okay, so we'll start off with the fact that they're perpendicular. The perpendicular fact of these two vectors, so 2a plus b, means that the dot product of those two vectors, when they're perpendicular, theta is 90 degrees, the cosine of 90 is 0, the dot product is 0. So that's the equation we have to solve. Now, FOIL. 2 times a half is 1, so this is just A dot A minus 1 half A dot B. That's that. Then we do plus 1 half A dot B, okay, minus magnitude of B, B dot B, I'm just getting ahead of myself. Those middle terms do cancel each other out. Oh, no, they don't. That should be 2. Yeah. Okay. So then I get magnitude A squared minus magnitude B squared minus 2 plus, okay, so negative 2 plus a half is negative 3 halves. A dot B's is equal to 0. Okay. So let's just keep going with that. I'm going to bring the dot product over to the other side. Okay. It's dot product, not minus. I'm going to use the definition of dot product because we're supposed to get the angle. Right now we have nothing with angle. So that's 3 halves. Mag A, mag B, by definition, cos of theta. Oh, there we go. So cos of theta then. Okay, so I'm going to multiply. I'm flipping sides and I'm rearranging and I'm writing on a new line all at once. Okay, so to get rid of the 2, multiply by 2. So I have 2 times that. Then I'm going to divide by 3 and mag A and mag B. And now I'm sort of stuck. What do I do with that? Well, we can fiddle around, if you like, with the different magnitudes. What do I mean by that? Well, if I, how do I want to do this? I need to use this fact right here. Okay. So I have 2/3. I'm going to go ahead and solve this for, let's say, B. So B magnitude is 3/2 A magnitude. So I'm going to replace B magnitude with that. So in here I have magnitude of A squared, and I'm running out of room. Let me write it over here. Give myself a little more room. Still have 2 magnitude of A squared, and I have magnitude of B squared. So I have 3/2 magnitude of A all squared over 3 magnitude of A, and B is 3/2, so 3/2 magnitude of A, magnitude of A. So just going through this, I have 2. I'm going to factor out a magnitude of A squared. 1 minus 9/4. Okay, and then the bottom, okay, I'm going to have 9/2 magnitude of A squared, which means I have the A's canceled out, the magnitude A's cancel out. I get 2. The 9/2 gets flipped, it gets 2/9. And I have negative 5/4. Oh, that's negative. I need more space. So let me just write that on the next line. Let's make sure I get that. Cos theta is equal to 2 times 2/9 times negative 5/4. 2 and 2 cancel the 4. So cos theta is equal to negative 5/9. And theta is equal to 123.75 degrees. That's it. So I'm just going to run through that because I kind of felt like I didn't talk my way through it very well. So let me grab a different color. First, the distributive, collecting terms, isolating. There's the definition of dot product. And now we're using this here. We're replacing magnitude of B. And now we're simplifying. And then we use trig to get the angle. And that's it for the video.